Right, 3D shapes again. Let's have a look at some of these questions. Okay, number 1. Here are some shapes of nets. For each net, put a tick if it folds to make a pyramid, put a cross if it does not. So what do we know about pyramids? Well, we know they're going to have triangular faces. So anything without a triangular face we can remove. So it's definitely not that one. So it could be either of these 3. Now, if we look at this one, if we think about folding along those edges, that's going to fold up. That's going to give us a nice little pyramid shape. This one here, if you fold these up, this is actually going to give us a triangular prism. So no thank you. This one here is going to give us a triangular based pyramid or a tetrahedron. So that one can have a tick as well. Remember, with all of these, with nets, it's all about that visualization. It's about that folding it up in your head. Okay, question 2 jumps over onto 2 pages. So let's have a look here. We've got a cube which has 2 shaded shapes on 3 of its faces. Okay, so what we're looking for here is we're looking for 2 edges. We're looking for this edge here where it splits a circle. We're looking for this edge here where it splits that shape. Is it a square? Is it a rectangle? Who knows? Okay, so think about that. Then we can overlay those over here. So I'm looking for those 2 edges where that's going to join. Now again, if you use your visualization in your head, you will see that this one here is going to join up here. And then we can see that when we fold the whole shape up, this is going to go somewhere else. So let's have a think about where that's going to go in a sec. But first of all, let's pop in our little semicircle. And if I can get a little curved line in here. So it'll look a little bit, wrong way around, look a little bit like this. There. Okay, so that's that first bit done. Now we've got to think about where this is going to go. So if this side's going to fold up, it's going to roll itself all the way around. Now we've got in the middle, this is going to become a corner. That corner is actually going to join up here with this edge here, which means that our next shape actually is the next one down. And if you think about that, if you fold that top down and then roll it around in your brain, almost like you're wrapping it up, you'll see where that's going to meet, where that's going to join. So I can just pop in my little bit of it's a rectangle on this face here, about there. And again, that visualization, that seeing that being able to fold that up is the key to being able to solve questions like this where it's asking you about the net. Alright, let's have a look at question number 3. Question number 3 is on a single page. So here's a cube. The cube is shaded all the way around, so the top half is grey and the bottom half is white. Again, we've seen similar questions to this. This one's probably slightly easier, but we are going to need to work out where these shading lines are going to go. Okay, so what you've got is we've got our one whole face shaded, and that's on the top, and that is this whole face here, so that's shaded for us there. You'll notice that on the other faces, so there'll be 4 other faces here all the way around, those are going to be half shaded, and those are going to be, if you think about where that edge is, where the face joins it, it's going to be the faces that join on with those edges, where they pivot around that point. So again, if you use your visualization, let's have a think. Okay, well there's definitely an edge here and here, which is going to involve both of these 2 shapes. So actually if I split those 2 like that, and then shade it in this section here, that's going to give me 2 of mine. And if you imagine folding along those edges, when that wraps up, you'll get those 2 half sides meeting up with the top face like we have up here. And then if I think about where else I can go with that, if I come back to here, it's going to have to be the other side that marries up with that edge. So if I look, I've got that edge here, which is going to be there, and then it's going to be along there, which is actually going to be these 2 shapes here. So then again, if I draw my line straight down the middle of those, that's going to give my 2 parts here, which are going to be my shaded shape, Okay, and then like our common sense mathematical check for that is almost fold that up in your head, fold the sides down, wrap the other two round. You can see that the shaded sides are touching the shaded center for both of these. Okay, and that's how we know that that one's going to be correct. Question number 4, we have our 4 diagrams. Put a tick if it's a net of a cube or a cross if it is not. So again, purely a visualization task with this. You need to kind of almost close your eyes, fold them up, and remember that trick of like pivoting the faces along the edges. Okay, so you're going to fold all of them up. The way that you'll know if it's not a net of a cube is if you have any that overlap, or if you have any that don't match up with what they're doing. And so if we think about this, okay, this is going to fold up to here. This is going to fold up to meter, that's going to come around over the top, that's going to come this side, then that's going to come back and form our lid on the top. So this is going to be one of our shaded shapes, so that can have a tick. This one here is going to be a tricky one because these will fold round here, but then actually this one is going to overlap with this shape here, with this face here. So they're going to be on top of each other, so you'll wind up with 2 faces on top of each other and an open top, so that's not going to work. Again with this one, if I fold this up, fold these round, I'm going to wind up with overlapping faces here. Okay, and the overlapping faces means that I'm going to wind up with an open shape. It's not going to be a complete closed 3D shape. So to think about this one, if I fold this one up, fold, 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 fold this one, that'll come round, flip the tops on, that's going to give me a complete 3D shape. So it's those two that are going to give me an actual cube. Those two are my nets. Okay, number 5 gives me a table. Information about 4 solid shapes. Complete the table for you. One has been done for you. Okay, so I have the benefit of being able just to drop in some 3D shapes here to kind of demonstrate this, but if I was doing this, you know, on a test paper, didn't have access to this, I'd probably just be drawing these myself. So I'm going to give myself a cone, I'm going to give myself a cuboid, and I'm going to give myself a cylinder. Now, chances are you'll know these anyway, but it's always that good sort of check to make sure that you're doing the correct thing when it comes to describing the properties of these shapes. Let's start with our cone. Number of flat surfaces. Well, there's a flat one on the bottom. Number of curved surfaces. Well, there's a curved one all the way around the outside. Tiny number one. For our cuboid, you can see here straight away there's no curved surfaces. A number of flat surfaces, well, it's like a dice, but a cuboid is not a cube, so it's extended, but it's the same properties. So that's going to give us 6 flat surfaces for our cuboid. For our cylinder, we've got a flat bottom and flat top. Think of it a bit like a Pringles tube or something like that. So that's going to give us 2 flat surfaces, top and bottom. And then if you actually ever open out a cylinder, you'll wind up with one long face that wraps all the way around. So that's going to give you your one curved face, your one curved surface here. So make this slightly larger. There we go. And again, just sketching those out, drawing those out means that we're really clear and really sure of our answers there. Number 6 asks us about this pentagonal prism. So we're looking for the shape that's the net of the pentagonal prism. For this, I'm going to need to know properties of the shape. That's going to help me out. So I'm going to have, let's just pop it up here. Let's have 2 pentagons. And I know that I'm going to have 5 rectangles. So thinking about that, if any of my nets down here don't have those, I can instantly discount them. So let's bring that down, let's have a look. Okay, 2 pentagons, 1, 2, yep. 5 rectangles, 1, 2, 3, 4, no. Definitely not you. Okay, 2 pentagons, 1, 2, 1, 2, 3, 4, 5 rectangles, could be that one, I'm not taking it yet though. 1, 2, 1, 2, 3, 4, 5, could be that. 1, 2, 1, 2, 3, 4, 5, could be that. 1, 1, 2, 3, 4, 5, can't be that because it doesn't have 2 pentagons. Okay, that leaves me with 3. I've eliminated the ones that definitely can't be. if I have a look here and here and here, I'm looking for the one shape that's a net. Now we know from network, or looking at nets, that you have to have the faces on either end of it. This one here, you can see straight away that these two are going to overlap, and so that cannot work. I can see here that if I fold these up, if I fold along the edges, I'm going to have an overlap between this face and I'm going to have an overlap between this face here when these fold up. So it cannot be this one. And despite this one looking like a strange net, actually if you fold all of these up, you're going to wind up, think about this as the base here. These are your sides, 1, 2, 3, 4 sides. Think of it standing on its end. This is going to be your lid on the top. Okay, so this one is going to work. That's our one shape that will work for this one. Number 7, here's a net of a cube with no top. The shaded square shows the bottom of the cube. Draw an extra square to make the net of a cube which does have a top. Okay, so again with these, if you don't print it out, if you don't want to print it out, you can just draw these in your book. That's absolutely fine. With this one, there's actually 4 places I can pop this cube. So if I just plant one there like that, there's going to be 4 different places I can put it. I can put it here, and that'll make me my cube that'll fold up to have a top. I can put it here, and this again will make me a cube so that I can fold up and have a top. I can pop it here, and that also works. But for the 4th one, I'm not going to tell you what that is. Answers on a postcard, please. Let me know where is the 4th place you can put that square to create the net of a cube which will work properly. Bonus points available. Question number 8, complete the table. So this one's quite nice. They've actually given you the illustrations here, straightforward. Cuboid, number of faces, number of edges. If you forget these, I mean, you could just simply count them and work out which bit's which here, right? So let's have a look here. Square base pyramid, number of faces, 1, 2, 3, 4, 5 square on the bottom. This one is tricky, however, because they've not given you the dotted lines which show you that kind of other side of the shape. Number of edges. So we're going to need to count these, and again I would just be marking these off as I'm counting. So I'm going to go 1, 2, 3, but I know there's going to be a 4th hidden. And then I've got 1, 2, 3, 4 edges that are going to make the edges of my square at the bottom. So I've got 4 and 4, that's going to give me a total here of 8. Right on top of it. There we go. Question number 9. Took the 2 diagrams that are nets for the triangular prism. Okay, so I can't use my last trick of writing down the number of shapes, faces I should have, because they've all got 2 triangles and 3 rectangles. What you're going to need to do here is you're going to need to do that visualization task. You're going to need to fold these up in your head. You're going to need to work out which ones are which. We're given a bit of a helping hand here. This is always worth looking at. 2 of these diagrams are the nets, which means that I'm looking for 2 separate answers, 2 of my 4. Now if you look at this one, stands out, right? That doesn't look like any kind of net we've done, and often if you think that, chances are if it doesn't instantly look right, there's going to be something wrong with it. I mean, if you visualize folding that up, it's not even going to make a complete 3D shape, so that's a non-starter there, which leaves me with kind of finding the odd one out. So 2 of these 3 will make a triangular prism, 1 of them will not. And the trick here is for looking for those triangular shapes on opposite sides. You can see here, if we fold this one up, these 2 triangles are going to overlap with each other, and I'm going to wind up with 2 triangles at one end of my prism and nothing at the other end. So that one is not going to work, which means it's this one and this one. 10 is over 2 pages, so let's have a little look here. Question 10. Open top cube. Here is the net from which it has been made. You need to put a tick on the square which is the base. So here you need to fold these up. You need to visualize that, what's going to happen, where is this going to go, and again you fold down the edges that are joined. So we'd fold this one, and that's going to fold kind of up here. You're going to fold along this edge here, which means that this bit is going to fold up here. And then we're going to fold these edges here. Although, I mean, with straight lines ideally. Which means that those two sides are going to wrap around to here and here, respectively. Which means that you're left with an open space in the top, which actually means that your bottom of this shape is here. Okay, and similarly with these questions, if you don't print them out, just draw it in your book, pop it on there, or just write down which one it is, or tell someone where the answer is before you check the mark scheme and have a look for yourself. There's always ways around printing this stuff out, you know, save paper, save the planet. Okie doke, let's have a look at question number 11. Question number 11 is on a single page, so here we go. A cube has shaded triangles on 3 of its faces. Here is the net of the cube, drawing the 2 missing shaded triangles. Okay, so with this, again, visualization, visualization, visualization. What's going to happen when you fold it? Well, we can only fold along an edge, and we're going to pivot the face, so this face is going to come up, this one's going to come up, which means actually that these 2 faces here are going to join. Okay, they're going to join, and the corners that are going to meet are going to be these corners up here. So this corner is going to meet with this corner here, and you can see that when you fold that up in your mind. And if I go back to my shape here, I can see that this corner in the middle is where all of those meet. And actually, if you then imagine unpacking this almost and folding this out, if we grab hold of this side here, and this side's going to come out to here, I mean, ideally without a highlighter, this side's going to come out to here. When that's unfolded, you can see actually you're going to wind up with a shape that looks a bit like that on that face. If you imagine that face extending out that way, you're going to wind up with a shape like that. So if this is the corner here, where these guys will meet in the middle, that means that I'm going to have a shape which looks a little bit like this, coming out from there. And then again, to double check that, fold that up in your mind. You see where they're going to meet. They're going to meet here and here. Yeah, that's going to work. Okay. Question number 12. Tom makes a shape from 4 cubes stuck together. 2 circles are drawn onto the shape, here and here. Tom moves the shape. Draw the circles on the shape in its new position. So this again is just kind of visualizing the shape, looking at how it's moved, seeing where everything's happened. You've got a gap of 2 here, look, you've got a gap of 2 here. So what Tom's done is he's taken a shape, he's spun it around, and he's stuck it on its end, like that. Okay, which means that your 2 dots are going to go here and here on the ends, like that. Again, visualization activity, and when you see that and you look back at there, you can see actually, yeah, you know, I can see that gap of 2, and I can see that there's one on that face, and there's one on the face of this pointing in the same direction. It's orientated in the same plane there. And question 13, is this the last one? It is. Question 13, look at each of these diagrams, put a tick if it's the net of a square-based pyramid, put a cross if it is not. Okay, so we've got 4. Things I know about a square-based pyramid is it has 1 square face, and we have 4 triangular faces. Okay, so we know that about it. That is important. Doesn't massively help because you'll notice that all 4 of these shapes have that property. Okay, so then it becomes a visualization task, and what we're going to be looking for here is we're going to be mostly looking for the shapes where there's going to be an overlap. However, if I come down to this one, if you think about a triangular pyramid, a square-based pyramid, let me pull one out here. If I think of a triangular pyramid, I don't really like this one. I think the perspective's all wrong, but it will do for now. And think about that. The 4 triangles all meet together at the top. Okay, and then there's 1, 2, 3, 4 faces to join together here. If I think about this shape here at the bottom, that's not going to be possible because of the way that the 4 triangles have been set up here. This actually, if I got rid of the square from that, is going to give me a tetrahedron, isn't it? If I think about that. If I chopped that square off the bottom, I've got my 4 triangles there. I'm going to fold them up, going to make myself a tetrahedron or a triangular base pyramid. So it's not going to be that one. So again, process of elimination, get rid of the most obvious one first. So I've got 2 of my 3 left. One of them's not going to work. If I look at this one, this is going to fold up along this line. Cool, that's going to come along here. So that's going to give me a face here and here. This is going to fold up along this line, and then this one's going to fold up and give me another triangle here. That's going to work. That's going to give me one that really looks fantastic. And then if I have a look at this one's going to fold up here. It's going to give me a face up here. And to this side, this one's going to fold here, which is going to give me another triangular face here. This one's going to fold, give me a face this side, but this one here is also going to come here. It's going to give me an overlap. It's not going to work. So then just double check. This one's going to fold up here, going to give me this side. This one's going to fold around here. This one's going to come to here, and this one's going to come to here. So again, visualizing that fold using the edges to help me out, I can see that those are my 2 that are going to work. These are my 2 that are not.